lograrlo también o solo streaming?
Como quieras. No sé si lo necesitas grabar. O cualquier cosa.
Cuando empiezan
Specialized teacher for your kids in artificial intelligence. So today we want to show you what your kids have been doing during this day, what they have learned, and also usually the head of school is here today, but Ms. Lila Jorge was not able to be here today, but we have a video of her, so we want to take care of those places. So.
Hi, good morning, vampires. I see so many familiar faces and new faces. If you don't know me, my name is Lila Jorge, and I'm the head of school at the Benjamin Franklin International School. We're so excited that you joined us for the AI Summer Camp. I'd love to thank Inspirit AI, our facilitators, Ruben and Anthony, and above all, our parents for believing and participating in this program and having your children be here today. This is the first year that we're offering the AI Summer Camp to our middle schoolers, so kudos to you, you AI pioneers. It's really important for us that our students and our new students understand the power of AI, but also that they do so and they use it responsibly and ethically. We're really excited too to welcome the students that joined us from right beginning, Carol Morgan School, AIS Kensington, the Schweitzer Schulen School, I hope I said that right, and Rwanda. We hope that you've enjoyed your time with us, and we're going to just say, come back next year, and congratulations for achieving all that you've achieved. Last but not least, we're really excited to be able to offer these types of programs because we recognize that the future is innovative technology. But above all, we need to make sure that you're using it ethically and responsibly. Last but not least, congratulations to getting this far. We're so proud of you, and we're excited to see the efforts of your labor with the presentations that we will be observing now. Congrats, and have an amazing summer.
Cool. Good morning, everyone. My name is Ruben, and this is Anthony. We're the co-instructors for the Inspirit AI program. We're super excited to show you all what your kids have been doing. I just want to take a second to say that, and I'm sure that Anthony is second this. I've told them this before too, that a lot of the material that you're going to see them talk about, we did not touch until undergrad or grad school. So it is just so impressive that they're interacting with it, that they're about to speak about it and present to you on it. I'm just so impressed every time I do this program, especially with these students. So without further ado, I'm going to pass over to Anthony to introduce his middle school students.
Thank you. Yes, I'm Anthony. Nice to meet you all. We're going to get started right away with a great project on movie recommendations from Brock and Felix. So yeah, please.
AI Movie Recommender by Rob. Introduction. Wouldn't a website that recommends movies be useful? Imagine, when you don't know which movies to watch, an app is here for you that recommends movies for you. What our app can do. Our app recommends movies for you. Recommendations are based on popularity, previous movie genre tastes, or user movie ratings. Why we made this? Helping people. This website can help many people that are struggling to choose what movies to watch. Sometimes I accidentally watch movies that are boring, and when that happens, it's really annoying. So I don't want that to happen to anyone else, and just recommend the best movies.
On everyday tools. When you're like alone from a tiring workday and you just want to watch a movie, the app just gives you the movie and you don't have to waste time searching for it.
How to use this website. So here you can choose how many popular movies you want the website to recommend you. And on the right you can see the movie score that the website put on each movie. There you can choose a movie you liked and the website can recommend you a similar movie to the movie you liked. Here the website can recommend you movies based on ratings.
Popular based recommendations. This movie recommendation method suggests popular films with high viewership and top ratings, which basically gives you the most popular films or movies of the time with the most higher viewership and the top ratings. Next is content-based recommendations. This system recommends top movies similar to the one you chose. For example, Spider-Man, based on your selected top films and a value for K for popular results. Basically, here you choose a movie, and then K is basically on the top movie. So, for example, if I choose Spider-Man and I put a value for K of 3, the app will give us the top 3 movies that are or Spider-Man 2 or 1 or are similar to Spider-Man. Lastly, we have collaborative recommendation. This system recommends 7 movies based on the ratings of 7 films you select. So here you select 7 movies that you like, and then you select 7 different ratings. So for example, 5, 4, or 3, and then the app gives you 4 movies that are similar to what you chose with the rating. So for example, if you chose Toy Story in one of them and you have a rating of 3, it may give you a movie related to Toy Story or Toy Story 1 or 2 with a rating of 3.2 or 2.9.
Conclusion. Overall, many websites and apps like this are fulfilling and getting introduced to this world every day. AI is changing this world, making everyone's life easier. Even though AI seems like unharmful and helpful things, it may take over the world after years and may become dangerous as years pass by.
Do you have any questions?
Yes, I have a question. So, what is the technology behind to build this?
Python. So we call it to find the different movies related based on keywords. So for example, in the Toy Story, the keyword are like toys. So to find a movie related to toys, to find a movie similar to Toy Story, it uses the keyword toys, and it gives you a movie that is similar with toys or a story about toys.
And you do really create a video report.
Yeah, but it's not like that you download it in App Store.
Yeah, but we can see it at home when you bring.
No, now we can see.
And will you show it to us?
So the popular movies. So for example, here we chose 20 movies, and then here are 20 top 10 or whatever number you want, and here are like the top 10 most popular movies. With, and here are the ratings of the movies put by the people who have watched them. Then we have content-based recommendations, in which you pick a movie. Does anybody want to pick a movie? Okay. And then you pick a value for K, like for example 3 or 4, 6, and here are movies that are or Spider-Man 2 or Spider-Man, or movies that are related to Spider-Man that are about action and superheroes. And then we have collaborative recommendations where you choose 7 movies. So
which movies? You can pick 7 movies.
So for example, all the 7s, pick 7.
Sabrina,
Good. And then you have to pick a rating for each. So for example, movie 1, 3, movie 2, 5, 1, 5, 4, 5, 3, sorry. 5. And then here, based on the ratings, it gives you some movies like 0 is 7, just mixes it up a little bit. And here different movies based on the 7 movies you have picked and the ratings that you would want to watch based on what you chose.
And how can the system get information about the recommendation?
We coded it and we made it like the system learned from like Netflix and these things. So we downloaded some files to the code so that the code and the website would know like how much every movie has like a rating or like how high the score is for each movie.
And as we said before, the keywords. It learns basically to find these movies, it uses the keywords of the movies at the top. So that's how it works, basically.
Yeah, for the similarity, yeah. So it depends on keywords.
So
There's a system to be programmed to be able to pick up. Okay. Very good.
that's it.
What was the most challenging thing?
And
What most difficult thing to make it work?
yeah, coding it, we had many like errors, like syntax.
And what did you learn from that?
And we learned how
Also
to
called apps,
overcome those like errors.
and how to code apps. Code it into giving you all these movies.
And what, last question, what do you think you could do next after this that you have learned?
Something similar, but not with movies. Maybe recommending. Imagine you broke your knee. Maybe recommending what is the best way to have it better, faster.
Very good. All right, yeah, so next we have the chatbot, educational chatbot. So, yeah. Yes, oh, yeah. If you want, you can separate the boards.
Chatbots for education by Ganesh, Sarah, and others. What are chatbots and how are they related? Chatbots are artificial intelligence robots that can create messages and questions. Here you can see that the user asks the chatbot, tell me about black holes, and the scene was about this. We learn chatbots for not just for anything, but for education, because sometimes they can be used for bad purposes. One of the most popular chatbots that a lot of people might recognize and use is ChatGPT. Has anyone used it? Some chatbots are actually focused on different things. We focus on some chatbots called Narrow AI, which means we use them for different things. Some of us use them for reading, some of us use them for science, some of us use them for math, we use them for different things. discussing ethics during chatbots. And AI ethics are the principles that AI uses to be fair and non-discriminating. These help AI work in a way that they can function without hurting people and always have a controlled conversation. How about we discuss it in a good chatbot uses NLP, and stands for natural language processing, and to understand the meaning and context behind user queries, even with variations in word or phrasing. Chatbots have adaptive tones towards the emotions expressed in your text. And let me give you an example. For example, I feel sad about something that has happened, and I speak to the chatbot, which responds empathizes, and responds with a different tone, and empathizing the user and helping them feel better.
So as Sarah and Thomas explained about chatbots, each of us made our own. So mine's called Jenny, and my chatbot is an assistant that helps you with your education. As Sarah said, it's a narrow AI, and the narrow AI is a chatbot that is only focused to one topic and that responds you when you ask it about that topic. For example, I designed my chatbot for helping kids or just new people in science. How I did this was by feeding my chatbot with lots of different documents about different topics all about science. What I did by feeding it was I made it smarter and more accurate and faster when you asked it about science. And even though I can still answer you about other topics that you ask it, it is the best in this specific area, which is this.
My chatbot is called Violet, and it was created on one of my favorite subjects in math. The material I put in was so intended and could respond to questions, as well as material from math because of the 6 these type of chatbots are supposed to help people with like studying, homework, statistics, analyzing, and connected to. We created these chatbots with specific instructions to not just help with any daily questions, but help with education so that we can use help. We had to figure out straight up with code, help with websites, and get the PDFs to read it. And my chatbot's name is Nunez, and I'm gonna be talking about a bit about how it works and what I created it with that. And starting with learning support, and my chatbot provides tutoring and helps with assignments or anything related to problems that you might need help with. And Nunez was designed to help for human purposes and help in any problem that you might have. For example, a logical issue, an everyday issue, or a mathematical or academic one. And my chatbot is, I would say, different from others since he focuses on specific topics like highlighting black holes and science, physics, and technology. And in order to make our chatbot smart, as they previously indicated, and we had to feed them files. And on the corner of the presentation, you have the uploaded files. And for example, we uploaded files of emotional intelligence, as discussed before, is how the user talks to the chatbot and the chatbot responds with a different tone, and scientific documents, and how to help cheer somebody up with techniques like empathy and sympathy, and a couple more files related to science and mathematical issues.
So in conclusion, narrow AI are a very useful type of chatbots that can help you, as I said, in specific topics. This makes the chatbot faster and more accurate when you're talking with it about that specific topic in the program. But this also means that if we talk about about any other topics, it's not as good as answering about those questions. This means that this chatbot is better in some aspects, but it is worse in more aspects compared to other chatbots. But since it is the purpose to only be used in a specific field like we use science or math, it makes it a very useful type of chatbot. Any questions?
Yeah, I have one. Okay, there is an article, a recent article that talks about the fact that ChatGPT and other artificial intelligence like this perhaps makes people to think less, you know? Do you think less if you use ChatGPT, or do you think that you think differently?
I think you think less unless you're building, because you're just asking it a question and then you just respond, and then it just responds. You're not actually thinking it through and deciding if it's that thing.
But then I wonder, then you have the possibility of making more complex questions, perhaps.
Yes, but if it's, for example, an easy question like what's 1 + 1, you could just do it without asking the chatbot.
So it's similar like a calculator or something like that in this case.
So here we have an example of the chatbot media and classes.
And does anybody have any specific question you want to ask related to science, mathematics? No?
How long before the sun dies?
Okay, let's ask. So I answered you in a short answer. This can be modified with the accessibility here. Well, it said that the sun is expected to have about 5 billion years left before it exhausts its nuclear fuel and undergoes changes that will ultimately lead to its death. It will eventually expand into a red giant and then shed its outer layers, leaving behind a white dwarf. This process is part of the sun's life cycle. Any other questions you want to ask?
Hi, so thank you, this is wonderful, like I'm learning so much from you. So I'm a teacher and I worry that my students will copy paste, not even highlighting, just clicking the copy paste and post it as their answer, not even having read the question or the answer. So I wonder, how would you make these yours? How would students make the answers there?
So this is a frequent issue in schools, because as AI starts to evolve, people use it for different causes, and this is one of them. So what I would recommend, or what most teachers do, is use several websites, for example Quillbot, to analyze and predict if the text is AI generated. Or even if you can use the AI chatbot, this one, for example, to detect if it's AI generated or not, what has been posted onto the student's presentation.
Thank you.
And any other questions? Okay. Well, that's all. That's all.
All right, like I said, it's so impressive that the students are learning this topic, to be able to speak about them so eloquently. Yeah, it's just very impressive. This next group is our first scholars group, and they'll be talking to you guys about this project that they worked on related to astronomy, exoplanets, and a lot of other interesting topics. So without further ado, I will let them take it away.
All right. Today our project was Planet Hunters, which is detecting exoplanets using AI. Next.
Haven't you ever wondered what's out there? So exoplanets are planets that are outside of our solar system, and it's really easy to detect, and we can just do it by ourselves. Join us as we are monitor the brightness of the stars using a method called transit photometry.
So the transit photometry, a method that measures the light curve of distant stars for periodic dips in brightness. These are the results for exoplanets passing in front of the star, like that, relative to the observer. Next.
So what does this mean? So like a flashlight, when you put something in front of it, the light is being blocked. So as you can see, as the planet crosses through the star, some of the brightness that comes from the star or sun is being blocked. There's like a dip in it. And you can see this in an actual graph where there's the brightness over the course of time. And you see that there's a slight dip in how much brightness there is, which is how you know there's a planet. Next slide. So we can see this through actual code. So which can explain. So first we download the data set from the NASA Kepler Space Telescope, and then each row represents the brightness of the stars at like a certain time. And then we use the data frame flux data to get like all the data into one table. And then we subtract 1 from every value that's in the label column. Next slide. And you can see here, so this gets a really big amount of data, like there's a lot of data, you don't want to see all this, and it's really confusing to understand. So we separate it into a label column using all this command, and you can see here, it's only really simplified. You can see 1 and 0. 1 means there is an exoplanet, 0 means there's not. So you can see it in a simple graph. Next slide. And yeah, so I said here. And we use data frames using .look to make each label say like this is an exoplanet, this is not an exoplanet. And then we use lens to count exactly how many there are and how many there are not, right? And so here we can see there's 5,050 cases where there's not an exoplanet, and there's only 37 cases where there are exoplanets. And just based on this data, which one do you think is more? Do you think there's less exoplanets or more exoplanets? Less. There's a very little amount. So this imbalanced data makes sure that like, how do we know if it's like a glitch or just like a, like an irregularity rather than an actual planet? So next slide. Yeah, so we have this using graphs. And so this way we can see here there's non-exoplanets. It's really confusing. There's just random data and if there's no regularities. Well, here you guys can clearly see there's a pattern, right? There's a dip that's regular. And so I think you guys can tell just by the graphs what there is and what there isn't, right? It's really simple.
Okay, so I want to ask you all a little question. You don't have to answer, right? But what do you think, based off of this graph, is it an exoplanet or not? Just guess.
Yeah.
Yeah.
All right, I'm gonna take that as a yes. Next slide. Okay, congrats everybody, you got it. It was an exoplanet. And just like Emma said, you probably, for those of you who did guess correctly and said yes, you saw maybe a period, like a pattern within the graph. So basically, that's what shows that there's an exoplanet orbiting a sun, is this dip that is constant and keeps happening. So what the AI, in a basic terms, what the AI will do is it'll find that period, that periodic pattern, and it'll pick up one of it. Next slide. And then it'll basically fold that data and put it over more data. And if that matches, the AI will assume that there's an exoplanet orbiting that star. Next slide.
All right, now we've collected all this data, and now we just have to change it a little bit so that our model becomes even better. This is called augmenting. Now, augmenting data solves two big issues. The first one is that there's a high range of values in the data, because flux can go anywhere from like huge, like negative values to in the thousands, maybe positive. And so this makes it kind of hard to average out, which is what the AI needs to do. So what we do is a thing called normalization, where we turn integers in a list, even if they're negative, into a set of decimal values between 0 and 1, so that all the data values become close together, and the AI can more properly analyze it, which improves performance and consistency. The second problem we had was that we had very little exoplanet data. We only had 37 data points. So we used a thing called SMOTE, which essentially creates more data points for the data. Here, this is visualized graphically, where imagine all the orange points are non-exoplanets and the blue points are exoplanets. Obviously, there's a lot more, but this is a demonstration. The AI using SMOTE would basically find all the exoplanets, link them together, and then create extra data points between them that the AI can then use further train, which solves the problem of overfitting, which means that when we put more training data, which is different than the actual test data, the AI will be better able to recognize exoplanets.
And here's what basically this looks like. Training the AI without the SMOTE method, basically, here is the data. This is non-exoplanet data, and this is exoplanet data. We have 5,050 non-exoplanet data, and we have only 37. But with the SMOTE method, we can train with 5,050 and 5,050 each. And now we started using more advanced AI models like the MLP classifier. MLP is short for multi-layered perception. And basically, this was the results that we got from this model with an accuracy of 0.99, and which is basically 99%. And here is basically the confusion matrix. It's something you already saw earlier. And what the confusion matrix shows is our results. So here I highlighted in red are what the AI model guessed incorrectly. So here it guessed, it predicted that this was a non-exoplanet when it actually was. And here it predicted it wasn't an exoplanet. It was an exoplanet, and it wasn't. So we only, this model only guessed 4 incorrectly.
Now, optionally, we could also choose to explore other AI models, which really helps in allowing us to compare AI models, because if we only use MLP classifier, we wouldn't be able to really understand how well it does in comparison to others. So one I used was Huber regressor model, which had an accuracy of 98.2%. And this really just allows us to understand our results better and what they mean in the context of AI model training. Next slide.
And now, with those models, we add neural networks. Neural networks are basically methods of how it's a method of how the AI will process data, and it's inspired by how we think. And we started using a dense neural network, DNN, which did not give us very good results. But then we also added more layers to that neural network, which gave us much better results, with only 5 incorrect guesses from the model. And then last but not least, we used CNN, conventional neural network, which was our best one yet, with only 3 incorrect guesses from the model. So, in conclusion, through this project, we gained valuable insights into how AI can be used to detect exoplanets. As a group, we explored the fundamentals of AI models, learning the differences between linear and logistic regression and how they apply to classification problems. We also discovered the importance of data augmentation in enhancing the model performance and preventing overfitting. Most importantly, we deepened our understanding of neural networks, which form the backbone of many modern AI systems. Thank you.
You guys have any questions for us? No? All right, thank you so much.
Thank you so much.
All right, great job, guys. So last but not least, we have actually another group of students working on the Chatbots for Education project. This one was a little bit different than the one they worked on to a certain extent. They're going to dive a little bit deeper into how like these language models actually work, how words and sentences are actually represented by like numbers and in a way that a computer can understand. So super excited to hear that from them. Come on up.
AI chatbots for education. What have we been working on? Over the past 2 weeks, we've been taking part in an exciting AI learning course that introduced us to fundamentals of programming and artificial intelligence. We started by learning how to code in Python, one of the most widely used programming languages in the AI field. Through hand-on activities, we practiced writing codes, giving commands to bots, and exploring how logic and algorithm function in real-world applications. After building a solid foundation in Python, we moved on to our main task, creating our own AI chatbots. This project gave us the opportunity to apply everything we had learned in a creative and practical way. Using our coding skills for Python, we designed multiple chatbots capable of interacting with users, answering questions, and carry out simple conversations, as my friend will demonstrate in the slides below. The experience was both fun and challenging, and it clearly demonstrated how powerful yet approachable AI definitely can be.
Notebook 1. In the first notebook of our project, we were learning how to make our own AI system. To do something like this using Python, a coding language, first we have to decide what it should do, like answering questions or giving summaries. You then choose a model you want to use, such as a language or write, and set up its properties like how detailed the answer should be. Next, write instructions that tell the system how to help you. After that, you write Python code to connect the model with the instructions. Finally, make sure you test your system by asking it study questions and see how it responds. You can improve by changing the instructions or the model settings. So what we first did is we learned the basics of the chatbot, of course. We learned how to interact with it using threads, and we created a personality program. This is one of the examples that we were able to reach by the end of Notebook 1, and now we're going to show what the steps behind this were. So creating different personalities. You have to create the robot, of course, and give it instructions so they know what to do. To create a variable for our assistant, we used this here that we showed, and in this example, it shows it how we use it. We have to make sure we give the assistant a name and instructions, and depending on these, the personality of the responses will vary.
So here you can see the responses mean and very much with the description above you can see here, which is like, oh, what do you want? Right? So now we're gonna look at a block of text, and we're gonna see the simple definitions of some words. So def over here you can see is basically a definition of a function, so to make it work. Then here, like messages with a little bracket, and then here all the text over here is basically to define what the robot needs to do. So you can ask the question, right? So here is so the system can generate the response after analyzing it, and basically this is the response. Next slide, please. So we do this by creating threads, right? So first we're going to start with the basics. What is a thread? So a thread is basically a sequence of of messages over the user and the assistants. But however, what's like the difference between a run message and thread, right? So the threads is basically what I just explained right now. The messages is like an individual part of the conversation, where like when you text your friend, it's like every block of the WhatsApp, you know. And then the runs is when the assistant analyzes the text you just giving it. You just have given it to him and just responds to that, you know. Next slide, please.
And now let me explain Notebook 2. Our learning objectives is that learn how to add your own files to a language model and make the chat box to have a better response. And our process includes create the assistant, upload files, embed text, find relevant file, and generate answer. And first, we need to create a thread, and Young Lady has already said that it means a sequence of message between the user and the assistant. And according to the code, we need to provide a question in the form of string. And in this case, in order to test if it works, so I type how are you, and finally the response. And second, we need to define a function to get your assistant's response. And during the class, I'm struggling with the function called return. So according to the internet, it enabled to send the clean result out of the function. And okay, and also I have a questions about the symbol of E in the field of mathematics. And finally, it turns out that it is a numbers with a value of 2.71, which is perfect and precise. And then let's talk about assembling a corpus. Our process is to choose the subject, gather files, and upload corpus. And in the following code, I choose classic works, and finally it works. It's relatively easy. And I will elaborate embeddings. Basically, embeddings are a way to show data enabling tasks such as similarity comparison and classification between the documents. And in the following code, it's very easy to represent, and the mathematics, in this case, mathematics and statistics are very familiar, and the tiger and the lion are fundamentally are the same. And now I will elaborate cosine similarity with more detail. And cosine similarity is quite related with embeddings, and it's used to measure how similar two vectors are, and the range is from -1 to 1. And by the way, I want to add that vector is a quantity that has both magnitude and the direction. Okay, and let me explain the code. And in the code, the square brackets are used to get the content at a certain position in the data. And you can see that similarity between these types is 0.7.
I found the code and had everything together. And we had some checklists which were using vector stores, recommendation chatbots, and deploying a model streamlit. So vector stores are a specialized way to handle vectors, which, as Jason said before, they're just data points in undimensional space. So how do you make a vector store? So first you have your input data, which in our case is PDF files, which are converted into numerical vectors so the computer can read it. That's converted using embedding techniques, which Jason also mentioned. And then we have to index them. So they're stored in the vector. The vectors are stored in the vector store. So it allows the computer to get a data point and then find similarities. And then querying, you have to ask a question so the computer gets a vector. So in this code, we name the vector store MapPay study, and then we have to create an empty vector. Then we prompt the computer to ask us for data files, then ask for the files, and then we upload those files. That's what I did. Okay, so here we have to query the chatbot. So I asked what are the rules for differentiation, and then it creates a thread. That's what we mentioned before, and overturn your answer seen below. Another important thing that we didn't have in the third notebook was customizing personalities, so it's much easier for the user to engage with the chatbot in a meaningful and motivating way. So we said that it's a friendly tutor who patiently explains concepts with thorough explanation and creating analogies. For me, analogies are really important to grasp the content better.
So Streamlit is a tool that you can turn your model into a website, so people can chat with your bot and upload files and receive responses based on the upload content. So here you can see we write some code, and this one is me display a large title. So here is more code, and for example, this one is create a file upload widgets in Streamlit app interface with type PDF.
Project overview. In this project, we learned how to make our own AI-powered study assistants. Using OpenAI's tools, we built and improved our system with advanced features, such as integrating custom content, building specialized functions, and using vector stores to make our chatbots more effective. Along the way, we examined important ethical considerations, ensuring our assistant was safe and responsible. We personalized homework help to optimize learning. This project helped us with skills to create powerful AI tools that can transform education. Thanks for listening.
So any questions for them?
Thank you. Thank you for this. At some point it went over my head, but this is excellent. So I have a basic question for you. You are a group of 6 working on this. I think it's fabulous and amazing. How did you divide the work? How did you cooperate? How did you collaborate to learn and enrich our lives with this presentation?
So since we're 7 people, 2 people per each notebook, and me, I did the introduction, of course. So we each, of course, did all of the notebooks, but some people had easier time to do certain notebooks, and some had easier time to do other notebooks. Also, for example, we're both like just in middle school, not doing that much. He's very smart, so he did the second notebooks. That's basically how we divided the work.
Right. Thank
you. Yeah, to be clear, all the students like did all the work in every notebook, like kind of like together and worked through them together. But for the presentation, they kind of split up based on their strengths.
Okay. Any more questions?
Thank you.
All right, I think that's everything on our end. Don't want to keep you all too much longer. Usually they have some sort of presentation to give about like other in-spirit programs. I can feel free to come up to me or Anthony at the end. We can speak to you. You can get our emails and we can tell you about some of the other programs that in-spirit offers, including like kind of like research programs. So if your student wants to take what they learned in class and then like build, usually with a one-on-one like MIT, Stanford computer science PhD student, you can talk to us about that and about where you can get more info on that. So if they want to do something a little bit more directed and like personalized, now that they're past the Pioneers and Scholars program, they're able to do that. Yeah, I think that's all from our end. Thank you guys so much. Your children are absolutely lovely to work with. I was telling them today just how impressed I am by not only how curious they are, but also how kind they are, like to each other. I feel like we need more of that this week. So, yeah, thank you.
Thank you.
thought this was cool. It'd be nice for me, like, provide, did you see the first instructor, provide you answers? Like, what do you want to know?